if you don't get English, that will be a good time to leave. Just for my understanding, how many of you are running Kafka right now? Oh, nice! Oh my God, this is fantastic. I'm so happy. Okay, so I won't have to explain what is Kafka too much. How many of you are in production? Good number, nice, okay. So I hope that everything I say here is redundant because you're all monitoring Kafka really well and you don't need to learn anything more about it. Not all people are familiar with Kafka. There will be exactly one slide explaining what is Kafka. So it will be very high-level introduction to Kafka, but you can go back and fill in later if Wikipedia, maybe. Wikipedia is of varying quality. Okay, let's get started. Gwen Shapira here, going to talk about how to monitor Apache Kafka. Very important if you have Kafka in production or any plans to take Kafka to production, pretty important stuff. And I know it's 5 p.m. and we're all asleep, so this is recorded and you can all watch me later when you wake up. Last day of the conference is hard. Anyway, if you remember nothing else that I tell you, please remember that if you take Kafka to production, you have to monitor it. It is very important because otherwise you don't know if Kafka is up and down. You'd think that everyone is aware of that, but I was working with Kafka for about a year. I was doing consulting. My second gig at Confluent, I think, I went to a customer on site, very big financial company in the US. They do credit card processing. And I show up there and I say, hey, can you show me your monitoring dashboard? Because it was kind of operational check and it's a good place to start. Show me your monitoring dashboard. And they're like, what? And I say, okay, you're running Kafka in production? And they say, yes, yes, yes. And it's processing my credit card transactions? And I'm like, yes, in production, yes. And it's up? Who knows? So we went in. They had a very high availability cluster, 5 brokers, everything replicated 5 times. And out of those 5 brokers, 2 were down. Basically, a Kafka process was not running on the machine. So I'm like, okay, we have an emergency. No matter what else you want to talk about today, we're starting with setting up Kafka monitoring because this is ridiculous, and you're processing my credit card transactions, and we can't let that happen. We worked all day. 5 p.m. I finish work, go back to the hotel, call my credit card company and say, hey, I need to cancel a card. Because, yeah, this is ridiculous. Anyway, so whatever else you do, please make sure if I ask you, hey, is your Kafka up? With every single broker on your cluster currently running, you should be able to tell me yes or no. That's the basics. In general, you may be wondering who I am. I've been doing a lot of database tuning for many years now. Started with Oracle and then a bit of SQL Server, a bit of MySQL. Suddenly, all my customers moved from Oracle to Hadoop, so I started doing Hadoop. And then I found myself doing Kafka somehow. Been doing Apache Kafka engineering for the last 4 years, I think, 3-4 years, something like that. I'm on the Kafka PMC. And in a weird twist of fate, I found myself as a product manager. I'm tweeting a lot. If you have questions now in 280 characters, you can tweet a very long question to me, and I can actually send a very long 280-character reply. This is a wonderful time that we live in. I promised to do a very, very short intro to Kafka. So this is Kafka for you. Kafka is a publish-subscribe messaging system that, unlike any other publish-subscribe messaging system, it actually stores all the messages for a set amount of time on your disk. This also allows it to act as a data source for stream processing, which is the other super popular use case. Kafka is a distributed system, so you're going to have a bunch of brokers. You're going to have logical topics. Producers write data into topics, and the topics are partitioned into different logical partitions. Consumers subscribe to those topic and partitions to get events. In order to be high availability, each partition is replicated n number of times, where on good systems n is greater or equal to 3. One of those replicas would be a leader replica. All reads and all writes always go to the lead replica. This is a bug and a feature, but this is how we guarantee consistency. The other two replicas will basically be busy trying to catch up with the leader. And the reason that we still have load balance between the brokers is that each broker will have a certain number of leaders and a certain number of follower replicas. Consumers can also be organized into consumer groups. If you have a consumer group with a bunch of consumers and they subscribe to a topic, each one of the consumers in the group will get a subset of the partitions, and together as a group they will be processing everything. It's a nice way to balance load between large number of instances of the same application. So Kafka from 30,000 feet, that's like 10,000 meter view. So with all those components, there is a bunch of stuff that you really want to keep an eye on. You need to keep an eye on broker health. Are my brokers doing okay? Is everything good with them? Brokers are pretty cool. They are important. They have to be alive. It's not enough. You have the producer and consumers. Kafka has what is known as thick clients, which means that the clients do quite a bit of the work for you, which means that we also have to monitor that the clients are doing their job. It's not enough to just monitor the brokers. That's like the second biggest mistake everyone makes, is just to watch the brokers. And then we're monitoring to make sure everything is alive, but usually while we check that everything is alive, we also care a lot about performance, our throughput, our latency. Oh my God, latency is going up, throughput is going down. So you use this data for performance tuning and some capacity planning. We'll talk a bit about how to do all of those. So starting with the basics, making sure that the brokers are alive and healthy. The way Kafka is usually being monitored is that Kafka has a plugin API for metrics reporters. By default, Kafka will emit all the metrics via JMX, and it's a lot of metrics. We'll talk about it in a second. But if you don't like JMX, and how many of you don't like JMX? It's kind of a terrible interface. You can plug in your own metric reporter. We have one that we wrote at Confluent. You can have, there is a bunch of those on the web, HTTP. Send data directly to Grafana somehow. There is a lot of those nice reporters. Figure out something, plug it in, and start using it. The problem is that there is a lot of metrics. Like you go to Kafka documentation, chapter 6 is operations, section D is metrics, and you just see pages on pages of gazillion metrics. And the second question every customer asks me is usually, do I really have to monitor all of this? And my answer is usually, well, I'm a consultant, right? So I say, it depends. That's what consultants usually say. It depends because in order to know if your cluster is alive, you don't need all of those. You need maybe 3 or 4 of those. In order to understand why it's not alive, on the other hand, you need another subset, and I can't tell you in advance which subset. The reason there is so many metrics is that every time something goes wrong for Kafka, for anyone in the world, because it's an open source project, after we do a postmortem, like, oh, troubleshooting would have been so much easier if we only knew this one extra piece of information. And as a follow-up for your postmortem, someone goes in and adds another metric to Kafka. So the number of metrics in Kafka kind of linearly existing, and as long as we have production incidents, it's going to continue linearly increasing. So you don't have to alert on all of them, but it's good to have a short history of all of them in case you start having to troubleshoot something. You don't want to play with too many things while things are down. But the thing is not to get distracted, because there's tons of metrics and only some of them are important to know if things are okay right now. The pictures that you see on the left of the screen is from the postmortem of the Challenger incident. I don't know, I mean, it's a pretty big deal in the US. Somewhere in the 80s, a very big space shuttle did not really make it. And apparently they could have known in advance that it will not make it, because they had all the data to know that it's trying to take off at a temperature that is not that good for the little plastic thingies that separate stuff. Anyway, so they had all the data, but they didn't make the right decision. A lot of reasons why you didn't make a good decision. Politics are always a problem. But is they always also had a bunch of charts that were kind of meaningless. They couldn't see the obvious that, hey, the spaceship is going to crash by looking at the chart. So it's really, really important to make sure that when you have a dashboard, you can look at it and say, Kafka is OK, Kafka is not OK in one look, and more important than you guys are smart. Your manager should be able to do the same. And if you have customers, your customers should be able to do the same as well. Everyone should be able to look at the dashboard and say, things are OK, or things are not OK. And if things are OK, and it's 3 a.m., maybe they should not call you and look at their own damn code. That's also very important. So you want to have this dashboard that people can look at and say, oh, everything is OK in Kafka. Let me double check my own client and not call Gwen at 3 a.m. I'm a big fan of that. Now, when you start building the dashboard, the first thing you want to know is if your Kafka broker, if your broker process is up. It's a process called Kafka.Kafka or Kafka.Kafka server, something like that. And one way to know if it's up is to have a small agent on the box that does PS-EF. Even if the process is not up, please send an email and say something. That's one pretty good way. The problem is that you now have to deploy this extra agent and monitor it. Some of you may already have an agent on the box monitoring a lot of stuff, in which case, perfect, all good. Some of you don't. Another way to know if Kafka is up is, well, you already have all those other metrics that you're collecting via JMX or HTTP or whatever. If you do not receive any metrics in a reasonable amount of time, say a minute or half a minute or something, well, you cannot really know that the broker is down. You know, maybe my monitoring process is down, maybe my network is bad, but I can get suspicious. And this suspicion is usually a good enough reason to page. So the first method is can be more overhead if you're not used to it. And the second is slightly less guaranteed, but one of the two you have to do. So pick one and go for it. The other thing you really want to keep an eye on, and that's probably the most important thing that you want to keep an eye on, is the number of under-replicated partitions in the cluster. Remember, we talked about replicas. Each partition has at least one leader and 2 followers. A partition is considered under-replicated if one of the followers is unable to keep up with the leader. So it basically either the broker crashed and it's no longer replicating, or for one reason or another, it fails to get new information, or it's getting new information and falling behind. The reason this is so important is, first of all, if your partition is under-replicated, it's slightly more at risk. You expect to have 3 copies of every event. Now you have 2 or maybe just 1. Not so good. But more important than that, pretty much anything bad that can happen to a Kafka broker or a Kafka cluster will result in under-replicated partitions. Like if I'm looking back through my support system at thousands of incidents we had in the last year, actually it's more, it's like almost 3,000 incidents. Most P1 issues, the way someone detected them was by looking and saying, oh, we have under-replicated partition. So it's a very good first indicator that something is really, really wrong. If you know in your car you have this check engine light, and you don't, it can mean a lot of things, right? It can mean anything, any sensor on the engine can turn it on, basically. And I don't really know what it means when it turns red, but I know that I have to go and get my engine checked because something is wrong. Under-replicated partitions is a bit like that. If you see an under-replicated partition, even if you don't know what's wrong, something is wrong, and it's a good time to go check. So maybe like a small blip is not a big deal, although worth investigating. But if it stays under-replicated, definitely take a look. It can mean issues with the cluster. Like, for example, you're running out of network between the brokers, so something cannot keep up. Or maybe an imbalance. A broker just has all the leaders or all the followers, and it's having trouble keeping up. It can mean an issue with the broker, bad hardware, another process on the same machine taking all the resources. I have a tendency to get violent with sysadmins who run antivirus on my Kafka machines, especially at 3 a.m. in the morning. It happens way more often than I'd like. Bad configuration on a broker. Someone ran Puppet and deployed something that was not approved. And very, very often, garbage collection. Someone may have sent a bunch of large messages to Kafka, and Java freaked out. That's a sad fact of life. So you see this happening, and then you kind of start drilling down. You look at the brokers. You look at the topics. Is there one topic that is under-replicated? then you know to focus. It's usually, you'll see like a subset of topics that are under-replicated, and you kind of drill down at the topic. If the under-replicated partitions are all over the place, it's usually like a cluster problem. You look at network, you look at imbalances, or you look at producers that talk to a lot of topics, and maybe they have an issue around that. If all the bad partitions are on one broker, you pretty much know where to SSH to and where to look. So that should be pretty obvious at that point. The obvious tip, it should be pretty clear by now. And then another type of monitoring that I always debate, technically it shouldn't be necessary, and technically it doesn't even test all that much. But pretty much everyone I know who monitors Kafka has a small shell script that produces an event, waits about a second, and tries to consume it, and alerts if the event is not there. And on one hand, it's not all that useful. I mean, you are checking at most one topic and one partition, right? I mean, there's a limit to how much the canary is going to test. But it's a very nice, very simple end-to-end test just to make sure that the whole chain is working. So up to you, but I think most people sleep better knowing that they have this one end-to-end test and not, it's maybe not 100% rational. Other important metrics to keep an eye on, active controller. I forgot to mention earlier, Kafka has a controller. The controller does leader elections. That's the most important job. If a broker fails and it needs to start electing new leaders, the controller will be able to send messages and say, okay, this leader is dead, you're the new leader, you're the new leader, you're the new leader, you're a follower, follow that leader, you're a follower, follow the other leader. It kind of, it basically acts as a traffic cop. You want to make sure that you have one and only one controller. If the number of active controllers goes below one, you have a problem. If it goes above one, you have a much bigger problem. It's split brain. Each one of them will send a different set of instructions. It's a very unpleasant thing that happens, and it happens for a variety of Zookeeper-related reasons. We fixed a bunch of bugs for Kafka 1.0, so hopefully it will happen a lot less, but that's definitely important, and that's one of the very few failure modes that may not look like under-replicated partitions. So this is really, really important to monitor independently. Other stuff to keep an eye on, Zookeeper disconnects. Basically, broker lost connectivity to Zookeeper. Usually, it basically looks, to Kafka, it looks the same as a crashed broker, because Zookeeper is how we keep cluster membership. So this will definitely look like under-replicated partitions. Unclean leader elections, super important. It should be disabled on your cluster unless you're doing something, unless you know what you're doing. Unclean leader election meant that a leader went down, and the new leaders that got elected does not have the latest messages. It's actually out-of-sync replica that doesn't have all the messages, that just got elected as a leader. If you get unclean leader elections, it means that you lost data. That's no way around it. That means absolutely data loss. So you have, if you don't expect it to happen, you have to make sure that this is at 0 at all times. In-sync replica shrinking expand, you don't really need it, because if in-sync replicas shrunk, it means that you have some out-of-sync replicas, which means you have under-replicated partitions, and everything is okay. You know about it, you already got an alert. Number of brokers is pretty important to keep an eye on. Again, you'll see it from under-replicated partitions, but if you expect to have 5 brokers and you only got metrics from 4 of them, now would be a very good time to start worrying. And the last Kafka health tip, really you don't want to spend your life standing there watching the dashboard. Configure alerts. If something happens, send me an email, pager duty, whatever is the most popular method of annoying people at 3 a.m. here in Russia. Make sure that you get that. And just a few tips on broker health, because this is something that a lot of people get wrong, so I figured I'll take this opportunity to educate you. Restarting a broker is not something that comes for free. Restarting a broker is tricky and dangerous. It used to be, if you're an older version, below 0.11, it's actually risky. There are edge cases where you can restart a broker and it will not be able to come back up due to some issues with leader election, position in the log, trend creation, and other stuff. We think we kind of fixed that, but you know, bugs being what they are. Definitely, it used to be a recurring pain point. Before 1.0, which is a very, very new release, like I'm thinking last week, I think, basically restarting a broker, especially if it had large number of partitions, was slow. I think that with over 1,000 or 2,000 partitions, it was already like 60, 70 second operation just to restart. In 1.0, we dropped it from 70 seconds to 3 seconds. And then in 1.0.1, we dropped it a bit farther to, let's see if I remember, it was below 1 second. So, by the way, dropping it from 70 seconds to 1 second, the patch basically removed one line of debug log. So you can probably look up the correct patch and do it at home on your own version if you really want to. Anyway, it used to be slow. It used to have some risk that the broker will not come up. And the really annoying thing is that our customers would do it all the time at the first sign of trouble. Oh, there is an exception in the log, so I decided to restart my broker. And you know, the exception was really an info, and it was an expected exception, and we handled it just fine. But now that they restarted this really large broker, and it didn't really start, and now we're in the middle of a 3-hour incident. So really only restart if A, you are 100% sure that you have an issue, and you have at least a good working theory on why a restart is expected to fix it. A lot of time, if you have, for example, a leader is gone and a new leader did not get elected, you don't want to restart any broker. You want to restart the controller, because the controller is, if a new leader did not get elected, there's a good chance that the controller either lost some kind of a message or lost the connectivity. Something happens that it caused it not to elect a new leader. So you can't just go and restart random brokers. So try to have, when I say metrics are not enough, it's not enough to have data. You need to have theories and models and plans on how reality should behave. So this is a very good place to have it on. Message delivery. That goes beyond, okay, my broker is okay. I know that my broker is absolutely fine. But do messages still get from producer to consumer? Maybe, but maybe not. Because it's not just the brokers that have to do something, it's also the clients that participate. So usually when you set up Kafka, you set it up for specific delivery guarantees. You expect at most once, at least once, or exactly once delivery. And you sometimes even have time SLAs. Your business expects your dashboard to reflect every message at least once within 5 seconds, right? So I'm doing a credit card transaction, and I'm looking at my phone to see if the transaction happened, and I have like, I don't know, 30 seconds to show something. And usually when you take Kafka to production, you make a promise to someone that you're going to get it. But do you know that you're actually doing it? Like, can you actually tell me that, yes, every single message made it? Not sure. So Kafka monitoring tip, it's not enough to monitor brokers. You have to monitor the events. You have to make sure events made it. And Kafka is really a distributed system. So the places to watch is at the clients. The clients produce events, clients consume events. They talk to each other via Kafka. Kafka is a distributed system, but everything that uses Kafka is part of that system. So how do we do it? LinkedIn invented what is now called an audit. And when I say audit, don't think about security, think about financials. So what we do is we count messages when we produce them, and we send kind of those side events that say, in this minute we produce that many events, in this minute we produce that many events. And then when you consume messages, we also count them. And we say, we consumed that many, we consumed that many. And we also look at the timestamp to say, oh, the messages that we're consuming right now, that we can see that they were produced 2 minutes ago, 1 second ago, etc. And you basically add those things up. You say, OK, I produced that many, I consumed that many, something is missing. And with just this kind of comparison, and this is very useful, like we did it at LinkedIn, and we did it at Confluent, and Uber did it, and a lot of companies that have Kafka have this kind of audit, because you can tell a lot of things about that. So first of all, you can tell when there is underconsumption. We produced n messages, but we only consumed n minus 10 messages. Why did that happen? Well, maybe my producer didn't have enough retries. So it did a send, and it even retried 3 times, but the broker was not up within 3 retries. So what do you know? We just lost the producer thinks it produced an event, but it never made it to the broker. or someone wrote a really crappy producer. He did a producer.send. He didn't handle the exception. He didn't even do a future.get to see if there was an exception. So the producer thinks it sent a message, but it never made it to Kafka. On the other hand, consumers that consumed a bunch of messages and then crashed without actually processing them, that can lead to underconsumption. And sometimes you even intentionally skip messages. Like your real-time application was down for an entire day due to something. You come back up. You know that you don't have the resources to go back and process an entire day. So you're like, OK, I'll skip all of those and go back to the last 5 minutes. Very, very common. At least you want to have a dashboard that shows you, hey, this application chose to skip 6 hours of data. Don't blame me if you're missing something on your dashboard, right? Not me, it's them. Because losing messages is kind of a big deal, few tips that we discovered. I get called every time someone misses an event because it's my application usually that detects that the missing event is missing, and they blame my application. Oh, no, our consumer and producer are perfect. We never lose messages. You are not counting correctly. Sometimes I have bugs, but sometimes I'm absolutely counting correctly. If you don't call producer.close and just, kill -9 your producer, producer.close does a flush. Producers have buffers, and producer.close makes sure that all the buffer was sent and acknowledgements came back from Kafka before the producer actually goes away. If you don't close the producer nicely, if you do kill -9 or you just forget to call it at all, you will lose messages. That's probably the most common way in the world that anybody ever lost messages. The other problem is not enough retries. By default, Kafka will have ta-da-dum, ta-dum, 0 retries in the producer until like 1.0, we are at 0 retries. You have to set it to something reasonable. And you can when I tell people set it to something reasonable, they say, oh, we'll set it to 3. Well, by default, Kafka retries every 100 milliseconds, which means that 3 will only last you, let's see, about 1/3 of a second. Well, leader election can very frequently, if your worker went down until a new leader is elected, it can take 6 seconds. It can take 1 minute, right? I already told you that in old versions, doing controlled shutdown can take quite a long time. So you need to know, hey, I want to keep retrying for an entire minute or 2 minutes. 3 retries are not going to do it. Make sure you're retrying for a reasonable amount of time, or again, you could lose messages. Make sure when you're doing send, you actually handle exceptions, either with a callback or by doing future.get. Do something. You just lost a message. Don't blame me. You need to do something. It's on you. And then use the new consumer. To upgrade to Kafka 0.9 or later. Very, very recommended. 0.10.2 is a very good release. You can try that one. And make sure you're using the new Kafka consumer. I know that upgrading clients is a pain in the ass, and I know that a lot of you are probably using the old consumer. New consumers are much safer. The auto-commit is pretty much guaranteed to never lose a message for you, which was absolutely not true in the old consumer, in which in the old consumer, I had an entire presentation on how to auto-commit correctly and not lose events. So I no longer do it because, hey, just use the new one. The other problem is overconsumption. That's way more common because unlike missing messages, which is usually bad, overconsumption is, well, we do at least once. It means that at least some messages will be consumed more than once. This is overconsumption. Very, very common. You did a commit, you ran a bit, you processed events, and you crashed. Everything since the last commit, you will process again. Usually no big deal, but it will be nice to tell your business and everyone who is interested, hey, events from this point in time to this point in time were processed twice. Make sure your database tables are all correct. Make sure your reports are OK. Let me know if you want me to reprocess or clean up something. Also know that it will impact your latency, because if you're processing events twice from half an hour ago, you're not processing events you're getting right now. As long as the trend for the latency is kind of reasonable and you can see that you're catching up, all good. If you're not catching up, time to maybe start new consumers and speed things up. And of course, the other thing you want to catch is slow consumers, especially if you have latency SLAs. You have to process everything within 3 seconds. And if you see that you have latency of 30 seconds, you're probably having a very bad day. Again, I hope you have more partitions and you can just add more consumers to your consumer group and kind of kill this backlog. or figure out why is your consumer slow and why is it suddenly lagging behind. Other stuff you want to monitor, you want to collect metrics from the clients. So far we talked about accounting, but clients have metrics, and a lot of people neglect to collect them. But you want to take looks like things like producer retries, especially if you kind of get close to the max retry number, you should get worried. Producer errors, large number of errors means that messages may get lost, and consumer message lag, especially trends in message lag. If you basically, message lag is how far behind the head of the log the consumer is. If it's falling farther behind, you should get very worried and try to do something about it. Okay, so far for clients. How do we tune performance of the broker, right? Because one of the things we get by monitoring is information about latency and throughput. We may want to try to improve latency and throughput. Tip number one, you want to tune the things that take time and not tune things that don't take time. It sounds kind of crazy, but a lot of people start tuning without even knowing what takes time. So this is the example on the left is something that a lot of my customers kind of tell me, oh my God, I've been looking at the log flash time metric and it's 14 milliseconds. What do I do? And I'm like, well, do you need to do anything? Is it high? Is it causing any issue that you should be concerned about? Is it a good reason for you to waste your time on? Is it blocking anything? Like, give me a reason to care about this number and then we'll talk. The right way to do performance tuning is to say, well, we have an SLA. We need to process that many events per second. We need to process every event within that much time, and we cannot really do it. So now we have a reason to care, right? We want to do something and we cannot. Why can't we do it? Well, maybe because a lot of the threads are busy, and I'll tell you how to catch it in a second. And then they're busy, but what are they busy on? Well, I did a bunch of JSTACs, and I can see that they're waiting for log flash. Why are we even doing log flash all that often? I mean, it should be a pretty rare event in Kafka. Oh, because we keep rotating log segments, and you have to do a flash every time you have a new log segment. Well, why are you rotating log segments? Maybe they're not sized correctly. Let's try to resize them to something that will not cause you all those issues. So you can that's the rational way of doing things. I have a problem, and I dig in until I think of a solution. Starting from a random number and say, I don't like this random number is not a good way to do tuning, and too many people do that. So the process I usually go through, we measure performance. We have this baseline. We figure out where do we spend time. We change one thing to try to make it spend less time doing that. We measure again and go through that until we're really happy. That should be obvious. In order to do this cycle, we need to understand where can time be spent at all. And the way Kafka works is that the client, producer or consumer, makes a request to the broker. It says, please give me data, or please take this data. And this request is caught by a network handler. This network handler, all it does is take this request from the network and put it in a queue. We have an IR handler that takes the request from the queue and tries to do something with it, usually either by writing an event to disk or reading it from disk. It's disk because Kafka heavily uses the page cache. And if you see Kafka actually waiting on disk, you have an issue. Or if you see the operating system freezes the entire world to free up your page cache, you have to start tuning your page cache. Anyway, so the handler does this local handling, but it's not enough. Usually it will have to wait for an acknowledgement that other brokers got the event, or that other brokers are willing to let you send the event to the client because it's committed. So you went for other brokers for information, and then you have a response. You put a response on a queue, and network thread sends it back to the client. Pretty simple. You need to be able to look at all those metrics at once. So for every request, you want to look at the total time the request took, and then the breakdown. That much time was spent on the request queue. That much time was spent trying to handle it locally. That much time was spent waiting for another broker. That much time was spent on the response queue. And given this breakdown, you can say what you want to tune. If you see that time is spent on the response queue, you have a network issue. If it's spent local time, you probably have a disk issue or a CPU issue. If it's spent waiting for other brokers, you have other broker issue. Go look at other brokers. This will let you save time by not tuning things that are not a big deal. So you found out that where you have an issue, look at the resources that this thing is bound on. Are you out of network, out of CPU, out of disk space, out of something? Out of IOPS, out of this throughput. Those are like the big ones. If you're not out of any of them, there is a good chance that you're out of threads. Kafka arrives out of the box, I think, with like 3 network threads and 4 IO threads or something like that. Most of you have a lot of cores. If you do hyper-threading, you have a lot of cores. Please use them. You almost always can add more threads before you need to start adding more machines, unless you ran out of network or disk, in which case threads are not going to help you all that much. If you think you have enough threads, time to start digging where do your threads spend their time. JStack is running JStack repeatedly and looking at the results is a good way to see where do all the threads spend all their time. I also have a very good colleague. He does flame graphs. That it lets you, it's a technique by Brendan Gregg from Netflix, I think, and it basically lets you chart where every thread spends its time by doing sampling over time. That's a very good way to figure out where threads spend all the time. I'd say that in our team, 90% of our performance tuning is being done using this method. Okay, so suppose that you figured all of this out and you solved your current problem. You also want to look a bit ahead and start planning. Right now, CPU is fine, but is there any dangerous trends there? Or maybe it's fine, but kind of high. Those are the big resources. Then there's our thread pools, which you can monitor the size of. CPU, the network utilization, disk utilization, all of those you need to keep an eye on. And the reason you need to keep a close eye on is that the important rule of Kafka is that by the time you actually reach high utilization for any of the big resources, CPU, network, disk, it's too late to fix anything. Because usually the way to fix it is I'll tell you, OK, so you're out of resources in your cluster, add another broker, take some busy partitions, and put them on the new broker, right? Well, guess what? Moving a partition from one broker to another broker takes A lot of network, B, a lot of CPU, C, a lot of disk access. Actually, more disk access than anything else that Kafka ever does, because usually it doesn't access disk all that often. So if you are already on the edge, it will absolutely tip your entire cluster over, and you'll have about 10 hours outage until we manage to dig you out of it. So really start planning when you're like 70% of any resource. Start planning your way out. Start even earlier if you're on-prem and you actually have to call someone to order hardware that takes 3 months to arrive. Oh, God. Try to call them when you're at like at 50%, just in case. OK, so let's summarize. You won't mind if I end early, right? We're all tired. Don't forget to monitor Kafka. If you understood nothing else that I told you for this entire 40 minutes, just find something to monitor. Just make sure the process is up. Just make sure the machine is up. Something, make sure that you know about your Kafka. Things to remember. You want to alert on things that are important. You don't want to get 3 AM pages about stuff that doesn't matter. You don't want to get into alert fatigue when you're like, meh, alert, meh, alert, meh, alert. Who cares? Because then you will miss the big one. So make sure you only get the big ones and you don't miss them. Don't just play around with shit just because you're curious. Like, definitely don't just restart brokers, but also don't spend too much time tuning things when you don't know what is the impact. So it's really, really important to understand how Kafka processes requests, how Kafka does leader election, and what is going to have a mental model of what will the impact of your action be before you do it. And it's a good way to also learn. Like, I think that if I add more threads, I'll have slightly higher CPU, but that's fine in my system, and I'll be able to handle that many more additional producer requests, and I do it, and maybe it happened, or maybe the broker tipped over and died, and now I learned something about what additional threads mean, about what is the capacity, what are my bottlenecks. Oh, actually, my disk was at full capacity, and I couldn't really do it. Oops. Let's go back to the drawing board and learn something from what I did. If you have absolutely no clue what you're doing, and some people don't, it's good to have support. It could be from us. It can be from any other company. If you don't know what you're doing and you don't want to know, first of all, you're probably not in the room, but maybe someone else in the company is like that. Cloud services are absolutely fine way to not know anything about operations. But the thing is that it's good to have someone on the phone, especially in an emergency, to kind of let you, hey, I'm planning to restart the broker. Do you think it makes sense? Because usually customers who already have support contracts, who pay us a lot of money for support, they usually call us 3 hours into an incident after they dug themselves very, very deep into a hole. If they'd call us before they took the first shovel, we could have probably saved them a lot of time and pain. So if you have a support contract, definitely just use it. And we have some time for questions. I'm also here. I'm leaving tomorrow morning, and I'm here all night, and I'm jet-lagged. So I'm also willing to exchange beer for Kafka advice if anyone is interested. Yes?
You're awesome. I have 2 questions. One question is about monitoring. Okay, monitoring is essential, but how we should deal with split brain? You didn't cover this problem.
Oh, how to deal with split brain? Restart both of the controllers, start one of them, wait for it to become a controller.
You say don't restart.
Yeah, no, if you have split brain, you're already in trouble. You don't restart for fun. If you have split brain, this is not for fun. So, okay, another good way to do it, you can go to Zookeeper and delete the controller node and wait for them to do controller leader election. This is slightly more risky because usually you're in split brain because someone lost connectivity to Zookeeper and did not discover it yet. So you can try, before you restart, you can try going to Zookeeper and deleting /controller and waiting for controller election to happen. But usually you will end up restarting both of them and waiting for things to stabilize.
Can we use monitoring to find the extra controller and forcefully shut down it?
Yes, absolutely. So the way you monitor active number...
Don't restart whole cluster, only...
Yeah, no, don't restart the whole cluster. No, don't. Please don't. Okay, the way you do it, every broker will have an active controller JMX metric to it. And it will be either 1 if it's a controller or 0 if it's not a controller. If you have more than 1 active controller, it means that you have 2 controllers, both of them have active controllers equal 1. Those are the ones to shut down. You don't have to shut down any other one.
What should happen if we kill not exactly that controller that we should? Okay, not master. Or master controller.
I didn't get that, sorry.
Okay, we have 2 controllers.
Yes.
How we can find which controller we should kill?
Oh, both of them. You don't know which one is the...
Any of them?
Both. Both, yes, definitely. Like the whole reason you have split brain, they don't know what is the real controller, so you have no chance of knowing either. There is no real controller. Everything is terrible. Shut down both of them. Someone else will become a controller, and this should fix things.
Okay, my last question, not about monitoring, but Kafka itself. About streaming processing case. What do you think about another competitors? For example, Apache Flink or Apache Spark?
Yeah, I don't think they're a competition. I think they are stream monitoring. They do a pretty good job. I used Spark streaming quite a bit before I started doing mostly Kafka. A lot of my customers use Spark streaming. A lot of them use Flink. In my opinion, I mean, we're engineers, right? Every software system has good parts and bad parts. I've had a lot of successes with Apache, with Spark streaming. I had a lot of really pain with Spark streaming. I've never used Flink, but some of my customers really like it. I'm good friends, at least with the Flink community. We hang out at the pubs and drink together quite a bit. In my mind, they are not competitors. They are part of the streaming community.
Okay, so
I've yet to lose a deal to Flink, for example. Like,
thank you.
There's someone back there.
Thank you for your reports. I have one question. Is it recommended or not to install Kafka brokers of the single cluster in a different data centers in different locations? Or or we must all brokers keep in one?
If the latency, so yeah, if the latency between the brokers is pretty low, then it should be fine. And we are running it, like for example, in AWS, we are running Kafka in multiple availability zones. And we like it that way. It gives us better availability, and it works just fine. Yes?
What's that no, how high or how low this latency must be?
So I can tell you what I tried. And when I tried it, it's important not to look at the average latency. You want to look at the spikes, because that's what gets you. When I did it, the spikes were to about maybe 10 milliseconds, but definitely not higher than that. On the other hand, I did not prove that it will not work with anything higher. So if you try it and you tell me, hey, Gwen, I just made it work with 200 millisecond spikes, I'm like, yay, go you. So it's not something we extensively tested. We tested it at pretty small scale with Amazon availability zone type of latency. So actually, yeah, I'd love to hear from other. I know that some people are planning on trying, like just farther away data centers. So it's something that I'd love to hear how people do. Like that's part of being in a community. And my watch just died, so you'll have to tell me when I'm out of time.
Thank you. I have a question. I'm not quite familiar with the Confluent platform, but there is some existing monitoring features or maybe tools in Confluent which can help us to monitoring Kafka.
Yeah, so my product is a Confluent Control Center. All the images that you've seen on the talk are from Confluent Control Center. Obviously, there is a lot of other ways to monitor Kafka, and I'm sure that a lot of you already monitor Kafka using your existing tools. But if you look for Confluent solution, Control Center is the one.
Hello. Hi, right here. Thank you for your report. One of my colleagues recently told me about this problem in Cassandra. When you query Cassandra for JMX metrics and you have a lot of key spaces, there was a bug which affected Cassandra performance. And I'm wondering if, for example, we have a lot of topics and we don't somehow filter all the data we gather through GMX, but just get it all. Can it potentially cause some problems, performance degradation on brokers?
That's a good question. I know that we had issues like that in the past. And actually that we now have nightly tests with the metrics that collect the metrics, because we definitely created metric objects that were kind of heavy when they polled, and they created an issue. As far as I know, it is not a problem with Kafka right now. But again, the number of topics we're testing may be smaller than what you have. So always good to try it on your system and let us know if you find anything. Yeah, not any. I know that we had this issue. I know that we tried to fix it, but I don't know if we fixed it for your numbers. So it's something that we'd love to know if you ran into an issue or not.
Okay, thank you.
Thank you very much. Can I get Prometheus format metrics from Kafka, or maybe write plugin?
Yeah, if you have metrics reporters that supports Prometheus, absolutely. Internally in Confluent, we just hired a bunch of SREs who really, really like Prometheus. So if there is an existing one, we'll probably use it very soon. And if there isn't an existing one, I bet that there will be one in about a month or so. It's something that, yeah, I don't know if there's any plugin exists, but I know that internally we are also very interested in Prometheus.
Okay, the news are great. Thank you.
Hello, thank you for the presentation. Maybe I missed something, but you said nothing about monitoring data quality, and actually I'm not sure if it should be part of such presentation, but in our company we have like 10 different TLAs producing 100 different topics, and a couple of weeks ago we had a situation where some TLA started producing data in the topic they shouldn't use, and It took us a while to understand what actually happened, and do you have any advices for your partners for such situations?
Yeah, I didn't put it in the slides because it's something we just started thinking about, but in recent versions of Kafka, there is headers. And it's very useful, we're thinking, we didn't try it yet because it's pretty new. If you use the headers to have every producer basically kind of sign his own messages. So if you see a bad event, you can actually know who sent it and you know who to call at 3 a.m. Even if you discover it at 5 p.m., it doesn't matter, right? You wait for 3 a.m. to give them the call. So that's one way. The other is something that we already have the data, so we're thinking of doing in our product. Because of the interceptors, because we're already counting messages going in and out, we know exactly which producers produce to a topic and which consumers consume from it. So we can we sort of just visualizing it. Like if anyone uses Airflow, you can get those nice visuals. Data went in here, went over there, went through there. So we thought about just visualizing the flows. But it's you can actually set alerts. Let me know if anyone other than those 3 producers is writing to the topic, send me an alert.
Thank you.
Okay, I think it's 5:50, right? I'm done on good behavior.
Any more questions?
No, if you have questions, we can take them later. I think it's a good time to finish.
Thank you.
Presentation.